Alrighty, so this is a little bit of an overview of rooftop unit installation or replacement. And so that'll be an important delineation we make between things while we're going is, are you replacing something that was there and you're replacing it with new? Is it just because it failed and so you're trying to go as close to like for like as possible? Is it an upgrade, like you're changing it for something that was there before but you're trying to accomplish something that the old unit could not? Or is it entirely new, where you're starting from there's nothing, there's a roof, and you now want mucho AC there? Yep. So we kind of tried to break that into things that if you're walking out to either do a survey or look at it or start considering it, what is it that you need to look into?
Basic RTU information and considerations. The rooftop unit, also referred to as a package unit when it's used in an application on the ground. It can still be on the ground for commercial purposes, but a lot of the times you'll see smaller buildings with package units that are actually exterior of the building and not actually on the roof. Size of the unit and what's around it. You have to be considerate about where you're putting the package unit. Obviously, it can't be in a walk path or something that's going to cause a fire hazard, or most commonly, even with residential, you'll see a condenser right outside the dryer vent. That is never a good thing. It's just going to clog it.
And obviously, if it's new, you're looking at then what now as your ducts drop into the building, what's going to be beneath that, like to make sure there's not any, you aren't adding expense. If you can just drop a duct right in it, that's relatively inexpensive. If you're having to relocate electrical or relocate fire sprinkler lines, you're now looking at a huge added expense. Or if you take that into consideration ahead of time, even if you have to jog ductwork a few feet after you come in, that's much less expensive than relocating an existing utility of some kind.
Of course, the weight of the current unit, if you are putting it on a roof, you need to make sure that the structure can hold the weight. Measurements, if it requires an adapter or if it's an existing unit that you can reuse the adapter. Same thing goes with the duct measurements. Overall situation, as I mentioned before, exhausts nearby. If it changes orientation, if there's electrical, if there's gas, and of course the duct configuration like Nathan mentioned.
And when we're saying orientation change, when you're replacing an existing unit, sometimes you'll have to have a curb adapter slightly in or slightly out, but basically everything's staying more or less facing the same way. If you are either changing manufacturer or changing what the unit's doing, you'll sometimes have a curb adapter or something. Or if you're ripping out a curb and putting a new curb, where just for size considerations, it's relocating as opposed to east to west. It's now going north and south, or maybe the fresh air is on the opposite side of where it was. Is the electrical moving? And so when we're saying orientation change, we mean sort of that duct orientation and then the length of the unit. Is it running front to back or left to right?
Yeah, and also keep in mind things like when you have a fresh air, that's going to be protruding away from the unit itself. So if you've changed orientation, now your fresh air could be hitting the building, or if your gas piping comes in from one direction, now it could have the ports direct against the other side of the building. Not that you would probably install it right up against the building, but it just keep all the aspects in mind. Make sure you look at your submittals for your new equipment versus what you're looking at with the old equipment. And then, of course, a little note about the unit require reheat? That's obviously, I've only seen that in commercial applications, but in some cases it does have a big effect on the job.
No, I mean, and that's something to look into when you are replacing a unit that's there. You can't just show up and be like, if it was a 5-ton unit, I'm putting in a 5-ton unit, or 20-ton unit, or 50-ton unit. You have to look at what was that old unit accomplishing. So what is it doing for humidity removal? What is it doing for fresh air? To make sure that if you're quoting to replace something, so this isn't one where somebody already did engineering for you, but this is you're showing up to a customer who you're quoting it. You want to look into how do we make sure that we're delivering something that's as good or better from actual what it's doing. So you aren't changing something that then, well, hey, my store, this used to be super dry or it used to be not stinky, and now what changed? And it's just that you went straight tonnage for tonnage match, ignoring everything else.
And I did miss the will it be exposed to coastal environments, which is very important. So if you have an RTU and it's going to see a little bit of salt spray from being close to the ocean, it's gonna deteriorate pretty quickly. So you have to make sure that you have it coastal coated so it lasts a little bit longer. I mean,
And
it
the
still
am-
has a shorter lifespan, but
and the amount that you want to look into that varies how close that it is. So I think normally you start thinking about it if you're within 5 miles of the coast. If you're within like line of sight, or you're literally coastal where there's wave spray coming on it, that's where you're going to want to look at something. Either A, the customer needs to know this won't last, or B, you need to look at something that isn't just your standard tin over copper construction,
Yep.
because it's not going to hold up. Like, you're looking at pretty limited time. Other, which we'll get to a little bit later, but when you're looking at those coastal environments, you need to even consider that when you're flying it off, that the unit may not be structurally sound coming off of the unit,
Yeah.
coming off of the of what it's on. And so kind of considering that, like, hey, I'm hooking up to fly this giant piece of equipment, I want to spend a little extra attention. If you're on top and you can hear the waves, the chances that it's going to fall apart while you're flying it go up quite a bit.
My question is, how do you know if the unit is going to be, or how do you know if the weight is going to be excessive?
So if it's existing, what you're looking for is your weight going up. If your weight's going up more than, probably more than 5%, I would say you're going to want to consult somebody before just assuming that it's fine. So you want it to be a near direct match or lighter, which typically isn't a problem. Like, the newer equipment tends to be lighter if you're just matching everything exactly the same. But if you are in some way upgrading the equipment, so you added reheat to a unit that wasn't there, or you added tonnage or something, then you'd really want to look into confirming the original drawings that told you how it could go, or told you what weight it could hold, to make sure that this is still okay.
and when we get to structural slide, I'll go into that a little bit more. But yeah, we can continue on. Rigging and signaling. So rigging and signaling, if you have any kind of interaction with a crane, you should really be versed in how to actually rig correctly and to signal them correctly. Rigging is connecting the load to the crane, essentially. So you need to know how to actually rig it in a place where it's not going to damage your load. It's not going to crush it. A lot of times that involves spreader bars. If you don't even know what a spreader bar is, then you have no experience with a crane. You should be certified. You should take courses in order to become certified to learn how to rig properly. It teaches you to inspect the rigging, teaches you to connect it properly, and it teaches you to pretty much just maintain safety. There's been a couple times where existing rigging has broken off of old equipment. Like, even with the coastal, it wasn't coastal environment, but it had broken off. There's been times where a crane has given me a strap that is half cut, and you have to pay attention to that sort of thing. And that's, like I said, the rigging side of it. If you actually go to get a certification, they teach you how to inspect the rigging. Of course, your crane operator should be doing this for you. You are kind of the backup. But it does teach you to look out for things and teach you how to properly rig it, set the bolts properly so you're not half putting in a bolt and then it falls out halfway through the fly. Signaling in the same way. If you're actually rigging, more than likely you're going to be signaling on the ground. Usually that's done by hand gestures if you're on the ground and the crane can see you. If you're doing a night fly, sometimes you use radios. Same thing. You do have a certification that is required in some commercial applications to have before you should be doing it on their property. This is just a sample of hand signals of the most basic signals you can see when you're operating a crane, and they all know these signals. Every crane operator knows it. Lately we've been using radio cues, especially when you lose line of sight. If you're in where the load is actually being set down, you need to be able to communicate without visually having any kind of connection to the crane.
And just even knowing the basic terms, like, a lot of times when guys are on it, you'll hear them, they'll just be like, up, up, down, down.
Yep.
And they don't know if you're telling them to boom down or boom up or cable down. And so cabling up or down is the actual drop, and that's going to bring you just straight vertical, where if you're saying down and you're booming down, that's going to move lateral along with it.
Or travel with your load while keeping your load level. It teaches you all sorts of things.
But yeah, I mean, things to look at that we've definitely run into is when you go to fly an old unit, we have more issues there than we do flying on the new one. making sure, like Dan said, that your attachment points are still good, they're in good condition, that they're tight, that everything's fine. I mean, things can still happen even when you check all of that, but you need to be checking it and not just assuming that it's fine. But then is there anything attached to the unit still? Is there, a lot of times people will hang duct from the actual bottom of the unit, and if that's the case, you have to check, is there anything else supporting that duct? So once I unzip all those screws, is a whole bunch of grease duct going to fall into the store? If you miss like a single sheet metal screw, there's into the side somewhere, it's a huge weight difference. Like the crane operator should know, if you've looked up and you know your weights ahead of time, he can tell you, hey, we're way off on weights, this doesn't seem right. You want to spend a lot of time there making sure everything is broke loose, because once you're hooked up, once the crane's there and hooked up and everything's going, now there's kind of a time constraint. And so a little bit of extra time from the beginning to make sure that nothing's welded down, there's no screws, your duct isn't hanging from the unit. Depending on the weight, you may even be able to kind of pry up on it as you go and make sure everything's broke loose so you can kind of see that it's ready to fly.
Yeah, most cranes can tell you exactly what the weight is that they're pulling on them. Of course, that includes their rigging. They need to know the weight of their rigging, need to know the weight of the actual ball. But then you can also, you'll have an estimate of how much a unit weighs, especially if you've been doing it repeatedly. So you've already done a 5-ton, you'll know just about where that load should be. So if somebody sent a 5/16 lag through the side of it and they're pulling up on it, it is a terrible thing if that lag breaks when it's got more pull on it than it actually should have. That boom deflection will make it fly up in the air. You can travel 10 feet and then it'll slap right back down on the roof. You got to be very careful about anything that's left actually keeping that unit down to the curb. So.
Yeah, I think any of us that have done it for a while have had things go wrong. And so there is like an inherent risk to doing things, even if you do everything correct. But if you're pretty haphazard, something bad will happen at some point.
Yep.
So it doesn't really matter what it is that you're flying. You want to take it sort of serious before it's there. Obviously, the heavier it is, the more serious you want to take it. But even a 5-ton condenser would do a lot of roof damage, or a lot of head damage,
or a skylight.
Right, or skylight damage.
Okay, crane pick considerations. Obviously, location, just like real estate. Location is one of the most important factors. Locating the crane over anything that it can actually crush with its outriggers or things that they didn't expect. Some sort of hollow spot underneath the concrete, grease traps, drainage systems. If they put one outrigger in the grass and it was, it's not like we go out there and do a ground test to find out how soft it is, but it could have disastrous consequences. Everybody has probably seen a crane tip over here or there on the internet, cut through a house, whoosh, just like a whip. It could be terrible and terrifying.
Yeah, and it is one of those things where, which is sort of the next part, but the total weight of everything, it is important to actually give some semblance of an accurate answer there. And that you don't want to be figuring out where your crane is going to set up the night that you're showing up to do something. Like that's a consideration that should happen ahead of time, because almost always when you see a crane that falls through or something sketchy happens, it's because somebody had no planning. What you had there to do the job doesn't work. And so then you're kind of trying to make it work at the last minute. Thinking through that when you're saying, oh, this needs a crane, just saying, hey, this needs a crane, unless it's something really, really light, isn't really enough. It's sort of, hey, this needs a crane and it should set up over here. Because particularly in light commercial, that happens quite a bit, where there's that, it'll be like, oh, well, this just needs a crane, like just quote a crane. Because you get used to, well, it's a really small unit on like a gas station, when you're like, oh, well, this is a mall, and this is like a 20-ton unit, that's an entirely different crane, and well, there's power lines or whatever. The thing we miss a lot with that is thinking through airports. If you're going to set up a crane, particularly a big crane, if you're within 3 miles of an airport, you have to get an FAA permit. If you're within 3 feet, you probably shouldn't do it. That's really close. I think we had one example where it was within 5 miles, but it was like a direct route of the takeoff path.
And you actually have to still get a permit if it's in direct flight of the path, I believe, 5 or 6 miles out.
Right. And so in general, if you look on a map and you're within, there's an airport close there, it's good to go ahead and submit instantly for the FAA permit, because you are looking at probably 30 days before that gets approved. unless you submit like a variance for emergency or something like that.
And obviously that's aerial miles, not I had to drive 5 miles this way and then 5 miles that way. So
No, I mean, those are kind of the crane pick considerations, power lines, and then you are looking at that. The biggest concern for them is people will sometimes give well, the crane pick is this big because that's the edge of the roof, where it's that lateral from where the crane could realistically set up, where would be the center point of their boom, to the center point of where they're setting is that boom length. And so if it's not a big enough job that you're getting it quoted, like the crane guy is coming and measuring himself, you still want to give, provided it's not really small and easily done by the smallest crane, you want to give that distance from center point to center point of the crane rotating.
and height. So you could have a 24-foot ceiling, but it's got a 4-foot berm on it. So that means that the crane would actually have to move its center point back in order to compensate for that extra 4 feet that it has to overcome to get the distance. So it is all about planning. And then of course, making sure that they know what they're lifting. That way they can pick the appropriate rigging to go with it, because the total load is, or the total weight is actually the load and the rigging. So you may have a 7,000 pound unit, you need to get 200 feet in, but if they have 3,000 pound ball on there, that reduces it greatly. The further away from it actually reduces your capacity of lifting.
Spreader bars are something that sometimes guys don't think about, but if you're carrying something that's pretty heavy, you don't want those straps to be impinging on the sides. That's where you'll get sort of closed doors and stuff. So the idea of spreader bars is to have it be wider than whatever piece of equipment it is that you're flying. A lot of that just depends on weight, and a lot of it's common sense. Like if you're thinking about, if I put straps on this thing and picked it up, is that going to bend everything? Then you need spreader bars. So you're picking up a 2-ton condenser, you probably don't need it. You're picking up a 30-ton RTO, you probably do.
Yep. And of course, weather. Weather is a big factor. You could have a crane out there, it costs a lot of money for this large crane, but you get washed out just based on weather. And it's not typically rain that causes it, but with rain usually comes wind and lightning. Lightning is the biggest factor, aside from wind. So wind will shut down the job. If it could be 3 mile an hour where you're standing on the ground, but it could be 17 mile an hour up there or whatever. They have to really take that in consideration, because you don't want a 14,000 pound unit blowing around in the wind on top of a crane. It's not safe.
Yeah, I mean, so it's something to think about when you're going in, even though, there's pretty good weather before a hurricane, it's a day and a half out. If you're starting to get weather in, don't try to sneak the pick ahead of time, even though it's not lightning or raining. Question?
Where can we get crane certified and will pay for that?
So for me, I do make sure that my guys get signaling and rigging certified. The biggest thing is there's actually 2 levels you can go through, and then there's an NCCO certification that you can do, and that's like the tippy top. But yes, for my guys I do. However, I try to make it so that it goes a lot slower, because I need to make sure somebody finishes before I actually just tell everybody to go ahead and get certified. You only really need one person that knows what they're doing on the job in order to work on that job. They can make sure everybody's doing what they need to do. But again, I want everybody to be able to do that, because at some point in time they're going to need to be able to rig and signal by themselves. It's always the next step when you're working with cranes.
So basically the answer is that yes, if that is something that you're doing regularly, then we can get that set up.
Yep.
Fresh air sizing. So we bring this up because on RTUs, that is most typically the way that commercial spaces are providing fresh air for the building. And so every building, depending on occupancy or whatever, has different amounts of what they call air changes per hour. So it's saying how much fresh air do you have to bring in to be able to ensure that there isn't built up stanky, high, right. Yeah, it is not too stanky. You got to turn that stank over. I think that's how it's said in the ASHRAE manual. But yeah, you basically have to make sure that over a certain period of time, every bit of air in the building gets replaced with fresh air to make sure that there's not anything undesirable building up in there. And that's going to vary quite a bit, because obviously a retail environment is completely different from something with gas cooking or a salon or something like that. There are published rates of recommended air changes. And a lot of times that's happening through the RTU. And so, and when you're showing up there to replace it, if you're doing this from new, well then you're probably going to want to have some kind of engineering done to tell you what you're going to need and make sure that that's sized appropriately. But it's something to look at if you're replacing an existing with a new unit, that you're able to move as much fresh air as this old one had. And so just knowing the tonnage of the unit you're replacing isn't all that you need to know. You have to look at that fresh air intake, make sure that it has the same capacity. If there's none, you don't need it. If it's there, how is it going to know to open and close? Is it going to run nonstop? What does that look like? What's cycling it? Is there something to just open that when it gets cool for free cooling? All of that
Economizer, yep.
is stuff to look at to make sure that you're replacing with what was there. And then, like we mentioned before, making sure of, particularly if it's not going back at the exact same height, exact same side of the unit, that you aren't now introducing something that wasn't there before. It happens a lot when you go from like an old Lennox to Carrier, you do it, but it does almost completely reverse where the fresh air is. And so now you're next to a vent stack or something, and you get a lot of that poo-poo stank coming back up inside. And an important thing to know is that if it's sized and balanced correctly, a fresh air is not going to increase your heat load. Where a lot of times people go ahead and close it off thinking that they're adding it, but all that air that you're losing, if you still have ventilation leaving, air is going to come back in somewhere. The building's not just going to sit in a vacuum. So every bit of air that you're exhausting has to come back in someplace else. Well, now, as opposed to bringing it through the RTU where it's going to be able to be cooled and dehumidified before it comes in, you're bringing it through every door closure, you're bringing it through your bath fan vent, you're bringing it through any loose windows, you're bringing it through places that it's going to receive no treatment before it's in the space.
Making it hard for customers to open the door.
So right, now if they turn off both the ventilation and the incoming air, well, now there is now there is a net and cooling gain, but probably some other unpleasantness. You want any building to operate in slightly positive air pressure. So when you open the door, it shouldn't blow wide open, the door should be able to close. But if you kind of hold something up in the air when it's opening, you should feel it pushing out, not sucking in. If it's sucking in, it means something's wrong and you're pulling in untreated air.
Yeah, you've probably occasionally or once in a while ran across a commercial door that is slightly pushed open because of positive pressure or whatever. It could be that their positive pressure is too high, or it could be that they just need to repair their door. But yeah.
Would that be something in a way that vestibules address, like with the pressure difference?
Yeah, I mean, so if you have a vestibule, so like an intermediary space, that's not really the term, but whatever, that space where you have like an entry and then a secondary door, that area is usually going to be extremely pressurized with that idea of preventing any mixing from outside to inside. So it's sort of like a, right, it's in grocery stores, you have it all the time where you have the one set of doors and then you go through a second set of doors. And that whole idea is, right, to create an area where there's heavy traffic that you aren't having stuff go from outside to inside. Here's a little table on the outdoor air calculation. Nothing super interesting there is what we've already went over. Distance between fresh air and exhaust. If you want to go ahead, Dan, on this, because it's...
We sort of covered this, touched on this a little earlier. Cooling towers 5 feet above or 20 feet away from intakes.
That's not something we see a lot, but if you do have a cooling tower, you're introducing humidity into the air. That's basically what it's doing. And so you're going to have the possibility of pulling that in. You don't want to be pulling 100%, like actually
humid air right back into your return. The 10-foot rule, essentially, everybody probably runs off of it. There's a little bit more in-depth things that can be there, but essentially you don't want to be within 10 foot from an exhaust and an intake. Intake opening should not be less than 10 feet from hot lines or buildings on the same lot.
So right, you can't vent out the side of the building right into your neighbor's building. You can't vent out the side of the building at head height right by a sidewalk or by a road. And so it's always 10 feet for whatever reason on all of them. And so you're pretty much just looking at, if I'm exhausting something, is it 10 feet from anything? If my intake is there, is it 10 feet away from any exhaust or anything that's going to be bad that you don't want to be pulling back into the unit?
If you're on a parking garage, you can't have it within 10 feet of the height of the road. You could be walking along a sidewalk getting blasted with exhaust air from the trash room. It's not a good idea. I like to look at this as a common sense thing. If you are replacing an RTU and you look down and it smells like a bathroom vent and there's a stack sitting out right underneath the air intake, that shouldn't be there. You shouldn't do that because that aroma is going to be sucked right up into the return air. Common sense, if you have a grease hood or something, you don't want to, that's why you see those long extensions on some, where you have an intake and an exhaust fan right next to each other. You try to take that away so that you're pulling in fresh air and not sucking exhaust air back from the kitchen hood right back into where they're trying to actually bring down the temperature and the smell and everything. So it's common sense. You don't want to smell the bathroom.
Yeah, I mean, I've had people say like, oh, is it 10 feet from like center point to center point, or is it 10 feet from the closest point to the closest point? And I think it is the closest point to the closest point, but it's still common sense. If you're replacing a unit that was there and you're not any closer than you used to be, well, what are you supposed to do? And it's close to 10 feet. If you're doing it and it changed rotation and it used to be like 15 feet and now it's almost 10 feet, well, you may want to look at, can you offset that a little bit to get a true 10 feet? Or, is it 9 feet, 11 inches? Okay, we're probably, there's some common sense there when you're looking at it. And what is it that is exhausting there? Is it 10 feet and it's a single small bathroom that's pretty well, there's a lot of airflow on the roof? Or are you in like a little alcove where there's a toilet exhaust and everything's enclosed in it? You're going to want to kind of look at that a little bit more.
And typically you can smell that when you walk up on it, so you'll know.
Electrical considerations. This is mostly to do when you're replacing a unit, but I guess it is all the time, even if you're putting new. But if you're doing new, presumably somebody has done some of these calculations for you and there's some engineering there to follow. But if you're replacing a unit, you want to look at it and say, hey, a lot of times there's a lot of options that you can select to replace this unit. And so if you're changing it to something that you have to change wire size, especially if it's a really long run, that expense change is a huge change. If you're landing to a breaker panel that has big square body breakers, that could be a $2,000-$3,000 breaker. And so considering that when you're going in, that if you can directly match it, that's sort of ideal. And so you want to look at what your existing wire is, get the gauge of that wire. That'll sort of correlate to a chart that gives you what amperage that's rated for. And if you ever see on a unit, it'll say MCA or minimum circuit amps, or I think those are really the only two things that it says there. That is how much that wire is rated for. And so you can't have a wire that's rated for less than that MCA rating on a nameplate. And so when you're looking through units to select them, it's a thing that happens a lot if somebody goes from a straight cool unit and they say, now I want a heat pump. Well, with a heat pump, you can have heat and electric heat happening at the same time. And so that possible highest amp draw is now higher. And so a lot of times when you're doing it, you want to select a heat kit that keeps you in that same MCA range so that you aren't having to change your electrical circuit going to it. That's true RTUs, residential splits, whatever. And then the existing breaker size on a unit, that's going to be what they call MOCP, maximum overcurrent protection, or sometimes it'll list max fuse size. And so that's saying what is the biggest breaker you can have on this. You can go smaller than that, you just cannot go larger than this breaker. The idea being that a breaker is what's providing that safety for turning it off if you're pulling too much power. And so that should be sized to that size unit. There's not really much else to it than that. You would also want the breaker to be above the MCA rating for the most part. And so sometimes there's a little bit of a gap there where there's a few options, but you want it to fall within that range. This is something to really pay attention to if the unit is changing or doing a curb adapter, is looking at, do your wires still reach? Does the wire and the protective sheathing on it, whatever it is, the conduit that's getting you there, still reach the bottom of the unit where you're able to terminate it? Most times it's not going to, unless somebody left you a lot of extra whip underneath or something like that. And so know that going ahead of it for, okay, how am I now getting this to where I'm going? Am I mounting a junction box down below? Is there somewhere here where I can whip it to outside the unit, put a junction box here, whip it real good, and then put a junction there to do it? Well, the thing that you can't do is you can't bury splices. A lot of people do, where they take a junction box, splice everything together, put it inside, concealed inside the curb adapter where you will never be able to get to it again, or between the roof and the roof deck, and then whip it up in. There's now no there's no way if anything goes wrong there that it is. When you're doing that, you want to make sure you are using some sort of rated lugs. You're not just using wire nuts in any of these applications. You want to use something that's going to be permanent, because no matter what way you do it, even if it's in a junction box below the roof deck, that's still a giant pain to get to. And so you want to use something like Polaris lugs or split bolts with rubber tape, or something that's not gonna come apart.
That's why it's good to just have your electrical come out separate, not through the unit.
Yeah, I mean, if it reaches, you can, if the wires do reach the bottom of your electrical box, and you can, extend the sheathing enough that it gets there, and then you can make your junction here, even if you have to extend that over to it, that's going to be fine as long as it's in a dry location. It just depends on what unit you're putting in. And so if you're doing a curb, or it's a curb adapter, but it's 10 inches, well, maybe we can make this work. If you're doing a curb adapter where it switches 90 degrees and also is 24 inches tall, it's not going to reach. You're going to have to figure out what you're going to do with that. I wanted to address weatherproofing at electrical penetrations or extensions, because this is something we did a poor job of when we were first doing things, because there would be sort of knockouts in the bottom of the unit, and you'd be like, oh, well, we'll just pull our liquid tight out through there, run it over to the unit, we're good to go. Well, then how do you seal around the bottom of this unit that's not in a weatherproof enclosure where there's a hole and there's something going through? So you do have to terminate your covering in a weatherproof way. And so if you're putting a junction box on the side, how does that, do you have a closed nipple with gaskets and seals on both sides? How are you making sure that you haven't just created a leak wherever your electrical's coming through? If it's not terminating at a weatherproof point at the base of the unit. If at any point it's exiting the weather protected side of it, and so how do you terminate the protective conduit down here to something and then transition to weatherproof conduit coming up in? There's not like, so you just have to have made sure that you've thought of that going in. Is how does this unit, does it have a weatherproof electrical thing, the electrical cabinet that goes to the bottom that we're terminating at, or is it terminating in a non-weatherproof location? And how are we making sure that that exit entry point isn't a point of water? And second would be disconnect requirements. Those can, especially as you get bigger, be different than the other ratings that are there. Each piece of equipment, each disconnect is rated to a certain arc flash rating, which has to match amp draw and all that. The one thing that I always want to bring up, because it saved me a lot of money and I wasted a lot of money before I realized it, is that disconnect, provided your wire's the right size and your breaker, your wire's now too big because you've downsized something, and the breaker is too big, so it doesn't provide the MOCP. Well, you could, instead of replacing this expensive $4,000 or $5,000 breaker, you could put some kind of a fused disconnect and now make that your point of overcurrent protection being there at the actual unit. Condensate practices. Dan is much more familiar with this than me.
So I did, when we're doing commercial applications, most of the time everything we have is pre-engineered. They tell us what we have to use. If you're tying multiple units into the same run, that does dictate what size you're going to be running. So if you have two 20 tons running down the same pipe, you still can't go with a 3/4 inch drain line. You actually have to accommodate for both of those lines to be draining at the same time. So this is just the basic outlook, is if you were running one drain to each of these units, this is what you would have to go with. It looks pretty much about 3/4 all the way, except for an AHU, which can be a 20, 30, or, well, I haven't seen a 20, but a 30 or 40 ton would be a 1 inch. It also happens to have gas lines for downstream of the regulator as well. You got to know the tonnage of the unit. You got to know how many units you're actually tying into the same drain line. The pitch of the roof, obviously you should have a 1% slope, which is 1/8 for every foot. So if you don't have that drainage, that pitch, if you're trying to go uphill because the end of the roof is flaring because the insulation was installed a certain way to go to a roof drain, you obviously can't go that route. You can't go upstream around the unit. If their drain is on the top side, you can't go in the opposite direction of the slope. You have to follow it all the way down. Pretty common sense, water don't drain uphill. So just make sure that you're installing it and it has enough pitch to actually move the water out of the drain pipe. You have to have a trap at each unit. So you also need to make sure that you have an air gap before you go into a catch can or some sort of a pan, whatever you're going into. You need to have the air gap, and the air gap should be double the size of what the diameter, inner diameter of the pipe is. So you want it to be down inside, but you want it to have enough air that the inside of that pipe is doubled on each side. So
So to clarify, this is if you're having multiple units tied into a common drain.
Correct.
Because what you don't want to have happen is the common drain back up. That first unit float switch turns off because the water's coming up to it. Well, now there's one higher up on the roof that just keeps draining, and now continuously is dumping water through 10 units that are all tied into one common drain supply. And so that's the idea of indirect drainage, is that you want an air gap. So if the common drain backs up, it's just overflowing on the roof. It's not overflowing through the lowest unit.
Yep. So yeah, no direct connection.
Does it matter? I've seen drains PVC and like galvanized as well. I guess there's a certain
I mean,
Doesn't matter.
PVC is cheaper.
galvanized rust.
PVC gets blown around a lot easier.
PVC
gets
over time,
rust.
you'll get the sags and double traps in it from the heat. So galvanized holds up better. It clogs a little bit more, especially when it starts to rust on the inside.
Make it taste weird.
It's definitely way more expensive. The other thing that I wanted to mention is no matter what you're draining is thinking through how you're going to support that drain. So appropriate drain supports that are somehow adhered or in some way not going to just the first time there's a light wind blow over and create a problem. And so making sure that you're supported in a way that actually works.
And obviously not laying on the roof decking. Just
Yeah, I mean, and this is something to check with your what we call AHJ, authority having jurisdiction. If you're going to be doing something where there's a lot of drains and there isn't any particular spec or there's no plans telling you how to do it, the code is very vague about that. It just says discharged to an approved and appropriate location.
yep.
And so by different AHJs, some will let you just sunlight it on the roof. You can just put a little trap, it's on the roof, they're like, thumbs up, it's good. Some of them say, no, it has to go to a gutter because it goes down to that's then going to a storm drain or something. Some will say, no, you can't put it in the gutter because that thing could have oils accumulated in it. It has to discharge to a grassy area. And so unless you're mimicking something that exists, if this is a new project or a building that doesn't have it, you have to contact and be like, hey, where do you want this going? Because it has to be an approved location, and obviously it can be really expensive if you had an idea for what that was going to be that's just like a couple feet. And then they're like, no, you have to run that to a grassy area that's on the other side of the parking lot. So figure out how to do that, sport.
Is there any rules of thumb on how deep they need to be compared to like maybe static pressure or something like that?
I mean, there is, but
Yes.
static pressure doesn't really go up by tonnage. And so unless you're working on a high static system, I think the manufacturer's recommendation is 6 inches.
Yeah, so yeah.
And it
So I
also
know what to
has
use
to,
2 of to measure that.
Yeah.
And the outlet, the actual size of your trap is dictated by the smallest point of the outside of your equipment. So like the inner diameter has to exceed the size of the opening coming out of a residential drain pan. So even at a 3/4 inch drain line, that's still larger than if you've ever looked in there, it's half blocked off. So that's why we typically use 3/4 there. Same thing with this, is if it typically you just pretty much match the port on the unit.
And so if the port is as far as sizing, just for a single piece of equipment, if you have a 1-inch port on an RTU, don't reduce
Yeah.
it down to a 3/4 inch.
Exactly.
You can upsize it.
Yeah.
There's no negative to upsizing it.
Except more expensive.
And in general, it's a rule of thumb. It's not really a code, but go up one size of pipe for each additional unit that's draining into this. So if you have 1 unit and it's 3/4, that's fine. If you're draining 2 and you go up to 1 inch once they combine, that's fine. If it's 3 1 1/4, once you go 4, you're at 1 1/2 inch, and that's for however many you're draining into.
Yep.
But trap sizing can change though, I mean, right, like as far as.
Yeah, but it's usually
Not really
only.
crap ductwork on it and it's like.
Yeah, no, I mean it can. And the easy test for that is if you have your vent port, however big your trap is, once it's draining, and you look at it, can you see it going? If you can, too low, right? If not, then there's enough weight there. The weight of the water has to
Like, if it's-
exceed the
if it's
inches
not
of
draining
static.
And you open the return and it drains, I mean, that would pretty much say that it's static pressure.
Yeah.
But if you go 6 inches, you're probably fine.
I have a question.
Yeah.
What sound was that it makes?
Look, I mean, it really is that.
Maybe you
I don't
can
want to.
soundboard.
I don't want to pat myself on the back, but that is exactly what it sounds like.
And just to bring that up, every manufacturer might say something different. Like even on Munter's systems, they come with a prefabricated 90, but on the outside, literally right next to it, it gives you the exact measurements of your trap and how to do it. So it's a big sticker right on the outside.
Yeah, even though they don't have much static because the
Yeah,
return air is
100%
all
fresh
of
air.
outside, so you have almost no negative static. Unit tie-down specifications, I'll let Dan go through this, but this is going to vary quite a bit. And this is basically, how do you make sure your unit doesn't fly away?
Equipment needs to be secured, especially here in Florida where we're hurricane prone. This can differ greatly.
If you actually look at different authorities and there is distance from the coast, and different areas have a must-meet wind load rating. And so most of your manufacturers who are making non-custom equipment, so it's just they've rolled off thousands of these, will have a spec for those different wind load ratings.
Correct.
And those are usually sized for the highest winds that this area has documented seeing in the last 100 years, is how they're coming up with that.
So, like I said, most manufacturers actually engineer their own tie downs. You can request that. This is a sample of a clip tie down method for Lennox. So we actually get the brackets, the correct tie down brackets, and we attach them by the measurements they show here and by the means that they request. So typically it's like a 3/8 screw. They're kind of small, but you can see that. Like that is actually the old style where it has roughly 15 3/8 lags on the inside and 15 3/8 lags on the outside. Newer ones we're doing more brackets, but only 4 on the inside and 4 on the outside. So obviously coastal environments may vary. However, what I'm finding is across the board, most people are just adapting Miami-Dade, the worst case situation. Even through the center of Florida, it just seems to be the common thing now. So,
Right, I mean, that's any major corporations tend to just standardize for the whole state. Or if you're doing like a one-off, well, maybe minimum is fine if you're in the middle of the state and you look it up and it's fine. The other thing is just to keep track then some proof of what you ordered or whatever in case an inspector decides to be a real pain, which has come up a few times, and you'd be like, no, here's the slip that came, because obviously your screws or your curb, the little tie downs don't have anything on them because it's a piece of metal. But if you do have the drawing saying like, hey, no, this is where I ordered it, and this is them, more is better with that, particularly if as you get coastal or you get into municipalities that are sort of notorious for wanting to fail you for things.
curb installation. Curbs are the way to install an RTU roof curb. Now, as you can see here in the example that I have to the right, this one is pre-measured for a taper in the roof. You can install a flat curb, which a flat curb is literally that. It's flat all the way around. So then that requires that you set the taper, meaning you have to reinforce the curb in some way. Usually it's pressure treated plywood or steel or something in order to get the level. You do not want to set a unit obviously off level. It won't drain properly. So most roofs have a taper in them, then you have to have a taper in it. The unit has to be level, but the roof has to have its pitch. So you have to match that. This is an example of something from a recent project we did. Obviously, I knew the pitch of the roof. I went there, measured the pitch of the roof, and then just verified the curb. I even signed the bottom of it, my little digital signature there. But these are much easier to install, period. You know, if you have a curb that's pre-tapered to the roof, best way to go.
Now, measuring that takes some doing because it has to be tapered, and you have to then think of where the supply and return are going, where does that correlate to the unit to make sure you aren't tapering it the opposite way you wanted the unit to go. And so making sure that you've thought through all of that and you're drawing in the fall towards supply side or return side or return side left, return side, you know, whatever that is, so that that taper, particularly if it's a two-way taper, that's going towards the corner you want, or it just doesn't work at all.
Yep.
Well, when you're ordering a curb, right, that's why it's super important to get correct measurements. So it's like when you get there and it's on the right size for the
Yeah, I mean, and so now this all becomes a custom curb order. And so if you're doing something quickly, you're going to just end up getting a flat curb. And the other thing to know, because curbs, these aren't curbs adapters, these are new curbs. So this is assuming that you're going into a roof that's there, either new construction or cutting into an old one. And the other thing to really think through with it is how much height does the roofing material have? And so you have to have, what is it, the minimum? I think the minimum is
14 inches.
14 inches above the waterproofing material to the top of the curb, because that's sort of You know,
Now,
to make sure that water
that
can't
can
get
be
up into
the,
it.
if you have a taper, that can be offset to the lowest point. So you can be 14 inches on one side and be 12 inches on the other.
Right, I still think the minimum is 10, but you're not going to have a roof that you're probably not putting a curb on
Yeah.
a roof that's that pitched. But right, that's for water penetration. You want it to be above the roof, and so sort of looking through that, which can be tricky if it's an existing building, but it's a question to ask on the front end. Be like, how tall does this need to be if you're doing new construction? How much foam is going to be up there? Normally, you know, a 24-inch would be fine because normally you have 6 inches of foam, so you're maybe losing 10 inches. But unless you have almost nothing, a 12-inch curb isn't going to work.
Yeah. And just to clarify that as well, you can get a curb adapter that has a taper to it as well. So if you show up and the general contractor just slap flat curbs all the way down, and you have all these units that are tilted slightly to the side because they happen to be draining properly because they're leaning that way or whatever the reason be, you have to plan for that because if you switch orientation, now you're uphill. So yeah, flat curbs are typically structurally connected to the building envelope.
Yeah, I mean, a curb is supposed to be on the structural of the building. It is not supposed to be supported by the roofing material. Right.
Yep,
Welded.
on the joists, yep.
Yeah.
Right. Anything over, what is it, 200 pounds
I think so.
is supposed to be
250.
supported by the structural
I've seen welded.
material, not
Yeah.
the roofing material. 200, below 200 pounds, I think you are allowed to support it. Below 200 pounds in an opening not exceeding 24 inches squared, I think you're allowed to have it just be on the actual like steel, whatever. It's just supported on there.
So like even with an exhaust fan requires that you have a picture frame be put underneath it if the hole is bigger than a 10 by 10. But if you have a 10 by 10, you can mount it directly to the decking with screws. Yeah.
So we'll switch to adapter. So this is once you have an existing curb and you're adapting to it. These are all usually going to be custom. Now, usually the manufacturers of them, if you give them the model number of the old one and the model number of the new one, they can pull all of those specs and make you something for it. The important thing to know is that there's nothing custom or weird about the existing one. So you want to look at it and make sure that, oh, this is on a curb that fits it. If you look on and it's already been kind of cheated, the condenser's hanging off 20 inches, well, now your curb adapter is going to be wrong. And so now you're going to have to start taking some custom measurements, finding some way of getting the actual dimensions. And so even if you look through the return and the return lines up pretty much directly there, well, now it's a safe bet that this is the curb that comes with it. But if you open it up and there's some weird transition in there and people have duckboarded a thing around. The other thing to know is you cannot install an adapter on an adapter. So if you're showing up and you're wanting to replace and there's an existing adapter, you're going to have to find some way of measuring where their supply is, where their return is on the existing original curb, not on your adapter.
Yep.
Oh, I've seen people do it, and it'll
yeah.
still set up there. Well, not only that, but it's like weeble wobbly as, you know, your weight is now distributed, because this one went over and now this one's further over. So you could like pull the whole curb that never got welded down over.
Yeah, that's another consideration, of course, when you're doing a replacement. If you actually see any kind of lean in the unit, even if it's gradual, you add a curb adapter on that and it's compounded. You can see it leaning crazy. So.
And so, right, you want to make sure the new unit or the old unit and curb are flat when you're ordering whatever.
And you cannot shim a curb adapter or you have an air leak. I mean, I guess you could make it so, but man, that would be a task.
Right.
Yeah.
No, there's no shimming the adapter, right? Because you then have gaps the whole way around because the curb adapter is usually your air pathway. And so if you do anything that even if you then seal the outside, well, there's still probably a gap between supply and return inside. And so that's bypassing air the whole time.
It's like taking a duct and just popping it loose to get it to turn a corner. And
The other thing that go ahead.
No, I was saying, I forgot what it was, but the adapter to the curb, I think it was every 3 inches.
what?
When you're tying it down to the curb.
I mean, that's
Okay,
going to
so
vary
that's
that's
varied.
another engineered point, but to the curb, right, that is a separate detail. The curb adapter to the curb is a different detail than the unit to the curb or curb adapter.
So typically it's 8 inches every center. So every 8 inches you need to have a lag in there on the bottom curb. On curb adapters, I've seen them use lags, but most of the time there's some sort of a securing clip or something like that you have to use.
Curb leveling, we already pretty much talked about
Yep.
it. You can shim the curbs, but not the adapters.
Yeah. And-
Leveling, like you say, is super important. The taller the curb adapter or unit gets, the more important it is. because obviously that compounds the difference.
And also, if you're tapering the wrong way and your drain is upstream, there's a possibility you're not tripping your float switch and you're draining right into the store. So,
No, it's not mine.
The so minimum steel requirements.
okay.
There's a lot of, he has some details, he can go over that because I'm not great at structural or know anything, but if you're putting in an RTU where it didn't exist, the absolute minimum is you need what they'll call a picture frame, or but basically the outside dimensions of the curb that's going in, you're gonna have to have some kind of 3x3 angle, 4x4 angle, something there that you can anchor the curb to. You can't just set it on nothing. And then that has to be attached to your actual structural steel some way, shape, or form, usually with some kind of panel points at the connection to make sure that this is not a place that can torque on the steel. So you're adding some sort of extra support where that frame attaches to it. That's like the minimum. Everything goes up from there based on wind load or anything else. But it's important if somebody's like, well, I just want a rough idea how much air conditioning I'm going to need to put in. I'm turning this old steel building. I want to have it air conditioned. Other people do that. Just give me an idea. You want to be like, okay, well, hey, this is the air conditioning idea, but that's assuming that there's steel for us to attach to, and that could run you, whatever, so they don't have this false assumption of it being super cheap.
Minimum amount of steel reinforcements defined as that which peak load at first concrete cracking and after steel yielding are equal. Concrete cracking is when the load causes the tensile strength in a member to exceed the tensile strength of the concrete. And steel yielding is obviously when steel is deformed in permanently deformed in some way, shape, or form. The biggest thing there is obviously you can't put a whole lot of concrete or a whole lot of steel on something when it's going to crush the concrete or crack the concrete. And you obviously can't, well, you could overload the concrete and then just put less steel on it, but they both affect each other. So your steel must be strong enough and engineered in a way to spread the support of the load across the concrete without cracking it. And you're obviously, if you put in concrete grade that was so low that it cracked under a steel load, then you'd have a lot more problems. But I've seen that before too, where they did not put the correct grade of concrete. It couldn't hold the pressure, and it actually cracked off corners. It's almost like when you put a footer in a building. If you don't have thick enough concrete and you roll your car over the edge, it cracks off the edge of the concrete. Same thing. Your building is standing on this concrete, and the engineer needs to know exactly what that concrete is rated for and how far they need to spread out the load in order to compensate for the extra weight you're adding to the top of the building. When you are performing reinforcement for an added load, typically if it's within a couple 100 pounds, 200 pounds or so, it doesn't make that much of a difference. But if you're putting an RTU where there wasn't one before, if you're putting a 7,000 pound system where there was a 5,000 pound system, or adding a curb adapter, usually that offsets the weight alone for added steel needed for a building, then you really need to address those issues. Otherwise, you're going to run into further issues down the road. Right there, as you can see in the picture, it looks like they had attempted to strengthen the steel, but they actually caused it to get weaker than when they started. You can overheat the steel, and you can cause the deform yourself. You can cause issues to happen. So being qualified, able to work on steel is very important. Really, all I can say is refer to your plans or your engineering specs for whatever you're attempting to do. If you're adding a curb to a roof, you should have some sort of engineering done. And not the normal person is going to be able to go out there and say, I can add 5,000 pounds to a roof. That is not something you should be including in your quote.
I mean,
Yeah.
and the reason to know this isn't so that you can do any of the engineering or whatever yourself, but to know that when you have that person who's like, come on, I just want to add one more unit to the roof. Like, you guys can't just add one more unit to the roof. And then be like, well, probably, but I don't know because there's a lot of stuff that goes into it, and I do it in your concrete cracks because now it wasn't right.
Yeah.
And so that's sort of it just sorts for people who want a company that's going to go through it and do it correctly, or if you're going to just throw it up there and hope that everything's fine.
Much less you won't get a permit. So I mean, I don't know of a place that'll give you a permit to add a RTU onto a roof without actually re-engineering and figuring out what's going on with the building to begin
You know, and
with.
you'll have people say crazy stuff like, well, can't you just say it's a direct replacement? And like, how would they know once they're there? I'm like, well, I'm not sure how they would know, but I'm not going to do that
And the
because
RTU falls through the roof after a couple
because this $400 of profit I was hoping to make off of you isn't worth me just doing that.
Yep. So, I mean, I don't even want to expound on that too much because for the typical person who's doing any kind of RTU, it's going to be a replacement. We really have only started this in the past few years. But without a map in front of you, the plans telling you exactly how you need to address something, it is really something that an engineer really needs to handle. You know, you can't just say, oh, I think it'll be good here. Let me add a little piece of steel here. It's not your shed. You know, it's somebody else's.
What if I
building.
want to add it to my shed?
That's fine. We can do that. You know, we can do that. Way.
The concrete on my shed is terrible,
Yeah.
but it's probably going to be okay.
Yeah. Yeah. Well, when we put an RTU on that shed, you know, we'll work on it. And that's pretty much it.
Supply and return dimensions are the outlet and inlet sizes of the airflow in the RTU. If you're looking at it and it's not clearly marked, almost always it's going to be clearly marked, but if you're looking at an old curb or something where you aren't sure, almost always the smaller one is going to be the supply, and it's usually going to be shaped square or near square. The return is going to be larger and usually rectangle. So if you have to just go ahead and count, the only time that wouldn't happen is if you have something that's bringing in a lot of fresh air, and so now you have only a little bit of return and a lot of fresh air, then that might be a little bit smaller. But for the most part, standard RTU application is that the return is going to be larger than the supply.
Supply and return dimensions, simply the outlet and inlet sizes for airflow of the RTU. They're found on unit submittals or footprint, but you have things to look out for. Curb submittals may not accommodate for full duct sizing, meaning your submittal for your actual flat curb or your curb adapter may not be the same sizes as what you're looking at the bottom of the footprint. So you need your submittal for the equipment and you need your submittal for its curb. Usually there's a slight difference, obviously, probably just because the physical exit of the unit is usually smaller. I don't know why, but it is. Maybe to accommodate as that being the inner diameter smallest part. But that being said, also with your curb adapters are a lot of times grossly oversized based on your duct sizing coming out of the bottom of the unit. So you want to keep static pressure down and keep that as open and breathing as possible. But in certain cases where you have like a retro curb, they actually have a lip that comes inside and it blocks off your returns. So if you match the measurements on the unit more than matching the openings on the actual curb, it's more accurate and you don't have to fight with this flange that is on the inside of it. So just physically looking through all the documentation, comparing sizes and making sure that everything is copacetic is the best method, because it'll save you time. If I got there and I'm like, well, I got to cut this flange off. Well, I can't cut this flange off because this flange intersects with a joist, or this is where I'm screwing it down. Dang it, I ordered my duct that was 2 inches too big and now I'm stuck in this situation. So plan ahead. That's the best thing I can say about it.
And carry lots of Pookie to fill them holes.
Yeah. And of course, planning ahead with location of curbs when possible can also prevent reinforcement requirements and duct obstructions. So if you follow the plans and you just said, hey, I'm going to put it right here because the structural plans say that, well then we go underneath the roof decking and we find there's a
12-inch fire sprinkler main.
Fire sprinkler main, right, running through, and the engineer didn't care.
I'm going to go punch Danny Driggers in the face.
every time.
Fire sprinkler, or you find out that if you, because a lot of times there's a little bit of play. What is it, like 3 inches off center of a joist when you're, okay. So you have that 3 inches, you can actually move, what, 1.5 inches this way and 1 inch that way and still be within spec. But if you move 1.5 inches this way, you could save yourself from putting a support underneath the bottom because it has to intersect with the rise of a joist webbing, right? So you could save yourself. But if you put it on this side, you're outside 3 inches. Now you got to add another one right there next to the one that's already there. So,
And that one happens to be in the way of an electrical conduit, so
Yeah.
you have to reroute that while you're...
so it's never just plug and play. It's always what's the best scenario within the specs that I have that the engineer has given me.
Thanks for watching our video. If you enjoyed it and got something out of it, if you wouldn't mind hitting the thumbs up button to like the video, subscribe to the channel, and click the notifications bell to be notified when new videos come out. HVAC School is far more than a YouTube channel. You can find out more by going to hvacrschool.com, which is our website and hub for all of our content, including tech tips, videos, podcasts, and so much more. You can also subscribe to the podcast on any podcast app of your choosing. You can also join our Facebook group if you want to weigh in on the conversation yourself. Thanks again for watching.